Hi students, I'm Praveen Sebastian Paul. In this lecture, we are considering a PN junction diode. A p-type semiconductor can be fabricated by doping small amount of trivalent atom to a tetravalent metal like silicon or germanium. Similarly, an n-type semiconductor can be fabricated by doping small amount of pentavalent atoms to a silicon or germanium. Due to the process of doping, the p-type semiconductors has more number of holes in the valence band than the number of electrons in the conduction band, and hence has hole as the majority charge carriers. Similarly, the n-type semiconductor has more number of electrons in the conduction band than the number of holes in the valence band, and hence has electron as the majority charge carriers. Thus, a p-type semiconductor consists of positively charged holes as majority charge carriers and negative charged immobile impurity ions and neutral immobile silicon atoms in its crystal structure. Similarly, an n-type semiconductor consists of negatively charged electrons as majority carriers and positively charged immobile impurity ions and neutral immobile silicon atom in its crystal structure. Additionally, due to the room temperature, p-type semiconductor has a small amount of free electron and n-type semiconductor has a small amount of hole as minority charge carriers. A p-n junction is formed by joining a p-type and n-type semiconductor together in a single crystal lattice. The term junction refers to the boundary interface where the two regions of the semiconductor meet. If the junction was constructed of two separate pieces, this would introduce a discontinuity in the crystal lattice, so the p-n junctions are created in a single crystal of semiconductor by introducing certain impurities called dopants, for example by ion implantation, diffusion or epitaxy, that is growing a layer of crystal doped with n-type impurity on the top of the layer of the crystal doped with a p-type impurity is an example. The p-n junctions are the elementary building blocks of almost all semiconductor electronic devices like diodes, transistors, solar cells, LEDs, integrated circuits, etc., and they are the active site where the electronic actions of the devices take place. For example, a common type of transistor like a BJT, that is bipolar junction transistor, consists of two p-n junction in a series in the form of NPN or PNP configuration. So when it comes to the construction, a p-n junction is formed by joining a piece of p-type semiconductor to a piece of n-type semiconductor such that the crystal structure remains continuous at the boundary as shown in this figure. Such devices which has one p-n junction is called a semiconductor diode. It should be noted that the p-n junction cannot be formed by simply joining or welding two pieces together because it would produce a discontinuous crystal structure. Special fabrication techniques are used to prepare p-n junctions. While fabricating a p-n junction, the following processes take place. First of all, the hole from the p region diffuses to the n region where they combine with free electrons. Secondly, the free electron from the n region diffuses to the p region where they combine with the holes. Thirdly, the diffusion of hole, that is from p region to n region, and the free electron, that is from n region to p region, take place due to the reason that there is a difference of concentration in those two regions. This difference in concentration create a concentrating gradient across the junction, and it results in the diffusion of mobile charge carriers across the junction. Moreover, the electrons and holes move at random in all directions due to the thermal energy. In doing so, some carriers manage to cross over the junction. The fourth important point is the diffusion of hole and the free electron across the junction take place for a short time. After few recombination of hole and free electron in the vicinity of the junction, a retraining force is automatically set up. This force is produced due to the depletion region which exists on either side of the junction. As a result of this, further diffusion of holes and free electrons from one region to other is stopped by this depletion layer. The formation of this depletion region is due to the availability of uncovered negative acceptor ion in P region and positive donor ion in the N region in the junction as shown in this figure. The additional holes trying to diffuse to the N region are repelled by the uncovered positive charge of the donor ions. Similarly, the electrons trying to diffuse into the P region are repelled by the uncovered negative charge of the acceptor ion. Hence, the further diffusion of the free electrons and the free holes across the junction is stopped. So these are the important factors while constructing or considering a p-n junction. Thus, the region containing the uncovered acceptor and the uncovered donor ions in the vicinity of the p-n junction is called a depletion region. Since the depletion region contains immobile ions which are electrically charged, the depletion region is also called space charge region. Due to the presence of only immobile ion, the depletion region behaves as an insulator. This space charge region establishes a potential difference across the junction. This is called as VB, even when the junction is not connected across an external voltage source as shown here. This electric potential, that is a VB, is called a junction potential or a potential barrier. At a room temperature, the junction potential or this potential voltage is 0.7 volt for silicon diode and 0.3 volt for germanium diode. So my dear students, these are the important factors considering a p-n junction. So as we mentioned, a p-n junction is formed by joining a piece of p-type semiconductor to a piece of n-type semiconductor such that the crystal structure remains continuous at the boundary, and it cannot be formed by simply joining or welding two pieces together because it will produce a discontinuous structure. Thus, the special fabrication techniques are used to prepare a p-n junction, and this p-n junction forms the basics of diode, transistors, LEDs, etc. So my dear students, hope you had understood this topic. So dear students, kindly go through this assignment question. Our question is, write notes on p-n junction diode. So my dear students, see you soon. In the upcoming lecture, we will discuss the biasing concepts of p-n junction diode. So dear students, see you soon. Until then, goodbye, thank you, and all the best.